So how to find the vertex of a quadratic function from the function? So first of all, we need two concepts here. The first one, general form of a quadratic function. That is, for every quadratic function is always equal to y equals a x minus h all squared plus k, where h, coordinate hk, is the vertex. So we need to transform the function to look like this. So here is now hk is now the vertex, which is what we are looking for. So secondly, how to make a quadratic function, a perfect square. Because if you look at the general equation, here is a perfect square. So assuming you are given a quadratic function, as squared plus bx, we always add b squared over 4a to make it a perfect square. To make as squared plus bs a perfect square. So as, that's add b squared over 4a to as squared plus or minus. This should be plus or minus. The result, once you add it, it will turn to a perfect square. And whatever that is in the bracket will be square root of ax squared, which is root ax, plus or minus square root of b squared over, that's square root of these two n values, which is b over 2 root a. So example, someone asks you what will be added to maybe 4x squared minus 2x to make it a perfect square. To make it a perfect square. So the answer will add, so my b here is minus 2, so I'll add minus 2 all squared over 4 times 4. So which is now 4x squared minus 2x plus 1 over 4. So we'll add 1 over 4 to make it a perfect square. And it will now turn to, as I'm just adding, the answer is 1 over 4. So it will turn to this. Square root of 4x squared is 2x minus square root of 1 over 4 is 1 over 2. So that's the perfect square now. Once you add 1 over 4, it will turn to this. So let's look at this question. That's the actual question now. We're asked to find the vertices of the following. So the first one, we need to add because I want to make x squared minus x a perfect square, so I'll add minus 1 because my b is minus 1 here over 4 times 1. I've added this, but remember we've changed the equation by adding that, so we need to subtract back to balance the equation. so that it will be like the original equation. So this minus this is 0. We are left with the original expression. So we've ended up at making this a perfect square. This is now a perfect square. This x squared minus and the result will now be square root of x squared is x. Square root of 1 over 4 is, remember, it should be minus because minus is here, is 1 over 2 all squared. So plus 5 minus 1 over 4. So our answer is x minus 1 over 2 all squared plus 19 over 4. Yes, because from our general form of equation of quadratic curve is always, if you could remember, is always y equal to a x minus h squared plus k, where hk is the vertex. Therefore, the vertex is half, 19 over 4. So that's what we are looking for, the vertex of this. So why the second one? What I will do, I will first factor. I'll factor 2, which is 2 brackets. I have x squared minus 7 over 2x plus 1 over 2. So we now start the main thing, which is applying making this a perfect square. So we add minus 7 over 2 all squared over 4 times 1 to make it a perfect square, but we need to counter by subtracting again. Minus 7 over 2 all squared over 4 times 1. So we have 2 brackets. This is now a perfect square. X squared minus 7 over 2x plus this is a perfect square, and it will turn to square root of x squared is x. Square root of this, square root of 7 over 2. So it's, remember, it's minus because of this minus 7 over 4 all squared. So why this? We just expand. We open up. That's 49 over 16. So let's add up. We have 2 in bracket x minus 7 over 4 all squared plus half minus 49 over, that's 8 minus, that's, it should be minus, okay. This is minus 41 over 16. So we still continue. So we have y equal to, we open up because we need to make it to look like this. Y equal to a times x minus h all squared plus k. So we can compare, we open up. So 2 times this is 2 times x minus 7 over 4 all squared. Y 2 times this is minus 41 over 8. Okay. We now have our vertex. Therefore the vertex is 7 over 4. That's our h. And our k is minus 41 over 8. So that's what we are looking for. So whenever you are given this type of question, you need to check if the coefficient is 1 before we start the normal process. Thank you.